when we need to communicate something to the parser about a specific grammar. That's what it's for. So that the parser can do things like print informational error messages that have specific knowledge of the grammar. Because our parser and the model that I'm following is that the parser implementation is not coupled with a specific grammar, which is unusual compared to other parsers. Usually, most parsers are made with very specific grammars in mind. Not all, but anyway. So, how do we do that? First of all, we have to decide what to name it. And then I'll just do the testing on that. I do not. I don't know. I'm kind of rethinking the AST one that's here. Again, once again, I have a problem with the fact that this PEGN library is both an implementation and sort of an interface package that defines how things are going to be used and stuff. So some of these sub packages in the module, like is that needs to go into res. Parser is a concrete implementation of this parser interface right here. So I will say this: at the top level, I'm following what I think is a pretty common convention of putting interface definitions and things like that. So when they're used, they resolve as PEGN dot whatever, PEGN dot parser, PEGN dot node, PEGN dot mark, and then I'm saving these sub packages for concrete implementations of those interfaces, of structures that fulfill the interfaces. But with the AST, I've been generating it as if it had been generated. So yeah. So we definitely have an AST interface that we need. So I'm going to go ahead and just make that. I don't need testing code, so I'm just going to combine them here. So I'm going to make a file called AST.go. And this will define any AST that you might have resulting from a grammar in terms of information about it. So package PEGN, and then what? Then we have a type interface, and we'll call it an AST. So a PEGN.AST. Now here's the problem, right? So this actually is a good example of the problem. So I have a PEGN AST that is the AST for the PEGN grammar as a grammar, as one of a PEGN grammar. PEGN grammar itself is a PEGN grammar. And then I have the notion of what an AST is in general, and those two things are colliding right here. Kind of, how's it going, Maz? So those two things kind of collide right here, because the PEGN.AST is like, oh well, is that the AST? No, this is an interface that defines a PEGN AST, and so I almost don't want to call it an AST. I almost want to call it like AST meta, or meta, or AST description, or it needs to be a. I'm going to keep it PEGN.AST because the way this is going to go down is that it's going to be used by other stuff. In fact, I should probably define the interface right now in the parser. So obviously the parser has to learn about the AST, which means I need to add an interface method here, which is going to blow up everything, because the hard-coded parser is no longer going to fulfill the interface, which is then going to blow up everything else, because it's going to say it's not an actual parser, even though the function signatures will say that's what's being passed. So right now we have to say the parser is an init. So right now when I initialize it, I am giving it just buffered input. So I can put a string here, I can put a reader or whatever. And I could do this. I could make it so that you have to pass in what the AST is. By the way, the AST is kind of a static thing. There's no moving parts in it. The really cool thing about this, it was a total accidental advantage, is that you can use the same parser and parse through the data, and you can actually change the grammar as you go. And I actually just answered my own question here. I do not want to put this here. I want init to be something to initialize all the buffers and marks the first. So init actually does send it back to the beginning, and I don't want to do that. So that says, hey, I have some new data here. I want to be able to change the parser in mid. I want to be able to change the AST context of the parser while it's parsing. So if I parse a specific thing, I want to be able to say, hey, I want to shift over to a different AST. Yeah, and we can do that. This is going to allow us to have this parser really be, completely independent of multiple ASTs. So you could actually have, combined grammars, which is kind of what I want to do. I want to be able. So let's say, for example, you create a Markdown file. Well, there's a CSV section in it, right? You could make a grammar that encapsulated both of those grammars, and then when it got to it, it could switch context and say, okay, I want to parse the rest of this using this grammar, and then you would see some kind of indicator that you're done with that particular grammar, and in the same parser without losing your place, you could switch it. So there's a lot of advantages to doing this, and I did not plan on many of those advantages, so super happy about how this is going. But that means that we do need to set the AST, which is just going to be an accessor. So and that will return an AST. Return the current AST context. I don't like using the word context in Go. Because it has so much loaded meaning now that they added contexts to Go as a thing. Contexts are a way of dealing with concurrency. They're used a lot in web development. I suppose I could make AST a context, which that might be. No. No, you're not supposed to put data in context. I'm kind of, if you know Go at all, that you might be familiar with that. So I'm going to use that word. Yeah, I want to almost kind of put like AST mode, because the AST is it's not the abstract syntax tree. It is the grammar's identifiers and metadata. You know what? I want to call it grammar. That's what it is. It's a grammar. It's not an AST at all. So it's a grammar, and a grammar. You know what? Oh my God, this is awesome. So the grammar can include the string that has the PEGN data in it. Fuck. And that means we have our own parsing built. Oh my God, this is really, it's like when a plan comes together. So the parser has a grammar. So it's the current active grammar. We're going to put that. That is a done deal. That is just too cool to not do. Did I spell grammar wrong? I guess I must have. Nope. So grammar. Grammar context. And then we have set grammar. Holy shit, this is awesome. All right. All right, and then we have set grammar. I could actually, I don't know. This is, it's, I don't know. This is hard because, This is hard because another way to do this would be to do this. Like has grammar. And then I put these two guys. I actually went down this crazy path when I first did the first version of this. Because, you know, there's kind of a rule that says you shouldn't have more than one or two methods per interface so that multiple things can implement it. And then you kind of compose them like this, like I'm doing. So yeah, yeah, but that's kind of annoying. So that way, I mean, like hypothetically, if you had something you just wanted to pass a grammar to, you could say, do you have a grammar? Yes. Well, okay, then I can do this. And then any other thing that it might do is up to it. And that's the whole idea of interfaces, right? So this is just saying, this is basically just giving the grammar property to the parser. And yeah, I mean, you know, I've gone back and forth on this so many times. I mean, at one point I had has expectations, has check, has mark, you know, has expect, and all this stuff. And I'm like, no, just put it all in there. So, you know, no, I already have signed off on this, so we're gonna do that. So that's really good news. It's really not the AST interface. It's kind of the grammar interface. Even though this video says AST in the title, we're not really interested in the AST. We're interested in the grammar and the information about the grammar, including the identifiers and all of that, which comes from the AST. I really like that because now it eliminates a conflict in the naming. So I can change AST.go to grammar.go, and I can start working on this. So this can now be grammar. So a PEGN.grammar. So what is a PEGN.grammar? Well, a grammar has got all of these properties, blah, blah, blah. The other thing that I'm really happy about with this is that this allows me to hard code building of the PEGN grammar, which already has its AST. So, you know, okay. So what I'm trying to say is that by convention, AST is the thing to be generated that contains all the parsing code for the AST. So that's auto-generated. And the grammar.go file is completely independent of that. So, in fact, I might even put a note in the README about that so I remember later. Jason, excuse me, okay. The AST package is meant to contain name is reserved, subpackage name is reserved for is reserved as the default for code generators. It should not be confused with grammar. No, that's fine. I don't need to say anything. I just want to make sure people know that the AST is going to get blown away and regenerated. That match a specific PEGN.grammar. All right, so there we go. So yeah, I mean that's really cool because that means that the implementation of the grammar interface can do the busy work of translating text. It's also where we can put eventually like runtime compilation of grammars, stuff like regex does. Which I really want to make. I mean, that is like the holy grail. If I can get that to work, that is the holy grail. Being able to do real-time compilation of grammars. And I need it to do my step highlighter and debugger if we're going to be able to do that. So you can just like point your step debugger of a grammar at a PEGN file, and then point the other end of it at some data that's supposed to match the PEGN file, and you can step through parsing of that thing. That is the holy grail. If I can make that, you have no idea how happy I'll be, because it'll be generic. It means it'll apply to any grammar that could be represented in PEGN. I can't tell you how much that just excites. If I was doing a master's thesis or something, I would, or PhD or something, that's what I would do. It doesn't seem very impressive, but you know, it would be enough probably to get me a PhD or whatever. But I'm not interested in pursuing that path right now. Yeah, I'm just not. I'm fighting off a temptation to go look at the WGU computer science program and see what their master's thesis project is about. And there's a mechanic who went through it on YouTube, and he got like a simple degree and just made an app for his capstone project. But he was getting his bachelor's. So anyway, back at it. So what do I need to do here? Okay, so let's go ahead and define the interface. And the cool thing about this is it's largely going to be independent of the parser development, other than the interface. So we need to set the grammar. Say grammar. We'll say a G. This is a basic accessor. Standard accessors in Go, idiomatic. They don't put gets on getters, but they do put sets on mutators. So yeah, that's all well and good. Set the current grammar. Yeah. I mean, there's so much stuff I have to clean up in these docs here. But, you know, I got into the documentation, and then I got trying to fix this little problem, which I thought was just a one-off error, and ended up, you know, sucking me into doing the errors better, which sucked me into doing the right thing in terms of grammar context. So, yeah, which is going to pay off a lot, and that would have saved me a bunch of redocumenting of a lot of things. That's the problem I have, is I always over-document too early, and then I change something, and then it's like, all goes to shit. I have to do it all over again. Because I do believe in docs, good docs. So the grammar interface. Well, okay, so the first thing we have is we have node types. So that we definitely have. So node types is an array of integers that matches the actual numbers. And then so yeah, so and then there's probably a couple of methods that we can put on this thing. So all right, we have a grammar. Yeah, I mean, I could make, I guess, no, that's more of a struct thing. What am I doing? This can't be an interface. What the fuck are you doing, Rob? I don't know. I'm I'm trying to think about this. So if I have, okay, so I'm thinking about optimization here, and I can't, if we have a function call for every node type lookup, that's going to take way too long. So we're not doing that. So what we need is we need an interface that's going to return the entire list of node types that can be cached before the parser does its work. And then that's just a map lookup. It's just an array lookup, so it's even faster. Hey, Exot. So it just has to go look up the corresponding array. So I'm going to have a node type and a node types. And node types will return an array of ints, array of strings actually. Because node types fundamentally are just ints. And so this is how you look up what their word is that goes with them. You need node types from string to int as well, right? You're going to need node types from string to int. From string to int. You're going to need it in the reverse, Greg? I'm trying to think why that would be. Oh, for the... Why would you need that? For the pretty one? The long form? Well, you know what? I mean, might as well provide for it. I almost don't want to provide for it because I don't want people to do that. Yeah, no, I'm with you. So the question really is, do we want to allow people to parse long form? And right now I'm getting kind of, you know, high and mighty about it. I'm like, no, you do not parse long form. If you have long form, you do not parse it. You only parse short form. If you want to parse long form, you convert your long form to short form. Well, you can't do that because you don't have the lookup, right? So I just talked myself into it. My biggest fear is, and I put it as strongly as I can in the spec, is that people are going to use long form for transferring data. It's because it's easier to read. And that would be such a disaster if that picked up steam, because it defeats the whole purpose and the whole motivation for making the thing in the first place. I want to use really, really compact ASTs so that the data that uses them, which I hope will be thousands and thousands of files at some point, from the knowledge net, is going to be communicated through that. And so I'm going to make sure to put that in the specification. It's like in big black letters. I'm like, do not use. I actually put the long form must not be used for storage and transfer. In other words, you must use the short form for that. But yeah, but you know what? I actually just thought of it. We have to use the long form. No, we don't. No, we don't. Because at least not in that case. There's enough case to have it there just in case it's kind of a punt situation. I'm sure we'll have to use this. We might as well put it in the interface contract. But if you have a situation where so let's take the testable examples in the README files that are going to be for documenting a grammar of any kind. So you have a code block that's got the grammar, or it's got a data sample that's being implicitly representing a particular part of the grammar, and then you have another code block that has the long form output from the AST that matches that example, that data example. And so to check that test, you just have to say, does this thing equal this other thing? But there's no requirement or need to parse the long form code in that sense to compare it to the other thing. That, in fact, it's quite the opposite. That would never be useful. However, but if somebody wanted to click on a thing and say, well, what does this look like in short form? Which might be nice. It might be nice to have to have tests in short form or long form. Then to do the reverse conversion is not possible. So thanks for that. I think I'm on board with that. Let's do node types, and then we need to do so we need to do node type. We need another one for what are we going to say? Node. I want to say type int, or what do I want to say? Node type. So if node type is passed an int, up for dev session is going great. Hey bot. Yep, PEGN.dev. Yep, thanks for that. I haven't been putting it in my status lines as much, but probably should. So yeah, so that's yep. So node type, I don't know what to call it. Anybody have any votes? I hate naming things. It's so hard. So because it's like that you're going to get the name wrong and call something like, I don't know, like HTTP requests, like that stupid thing they got forever code, Ajax HTTP request. It was a horrible name. I'm always afraid of naming. So node type. So the node type is going to return a string. I mean, I could do node type string like this. I mean, that's a really, really long fucking name. But it's not going to be used anywhere but here. Node type strings. No type as string. Yeah. Let's see that. I like that. This no type strings is good though, I think, don't you? No type as string and then no type strings. Yes. Yeah, I agree. All right, so let's do the opposite of that. So we can say node type is int and then pass it a string. This works. This works. I'm happy with this. String, and then we get an int. So these are sort of utilitarian. They should not be really used a lot. By defining them, people are going to use them, but they are slow, and I don't want to do map lookups every time. So but I'll let people make that decision for themselves. So that means node type as int and node types, node type int, integers, node type. I mean, it's long, but this is one of those cases where I'm okay with it, I guess. The node type integers, the node type strings. So if you pair those two together, you get really, really quick lookup. And so yeah, string int. Oh, thank you. Thank you, sir. No, that is not what it is. No. It's not what it is. It's a slice. It's not a map. Yeah, we're not using maps anywhere. I refuse. Maps are way too slow. So you can get a list of all the strings that one for one equates to the list of all the integers. Let's see here. That seems kind of stupid. We almost don't even need that one. Nope, we don't. We just need the node type strings. That's it. Because the constant number is the lookup. So we're not using a map, we're using a slice. Which internally is a hash, I know, but whatever. So the node type as integer. Undefined to 0. That's going to be a tough one. It might have to be an outlier. Yeah. Grammar to 1 then. Yeah, grammar's already 1. Right? So 0 is always undefined. That's a constant, which we need to. That's not an interfacey kind of thing to do, but yeah, it's like kind of. We can write about that though in the interface. We can say, look, the integer 0 is reserved for blah blah blah. I'm kind of glad we can do that because we can put some rules about how a grammar is represented to the parser in here that echo what's documented in PEGN itself. No type of string. This is really the important stuff right here. Which is no type as integer. That it's not. I took it out. Oh, that just returns the int that goes with the name. Yep, that just looks it up. Which we really don't need, right? What this does is if you give it a name, it will scan and find it. And find out which one it is. It'll give you a number. This is literally just returning the array entry. Does that make sense for the given integer, I think. Actually, this gives you what index in the map it is. Yeah. I don't want it to. I think we should get rid of it. I almost don't think we need it. Because the only way to look that up is to We really only need the one. I mean, let's make a case for me again why we need to look up the integer. No type strings. Parsing the pretty AST. Yeah. Fuck. I mean, I don't look. I hear what you're saying, and this if we're gonna do that, this actually argues to make that a map instead of an array. But because then you get all the advantages of like the hash algorithm that deals with the map instead of writing your own, which is what we'd have to do. So if I left this in here, we'd have to write our own hash algorithm to do whatever sort and search of the array. We'd have to write our own. And I'm not opposed to doing that, but I don't want to incur the performance cost on the int string lookup by having an index as an array in an array, indexing directly into an array, which is really fast. It's the fastest possible thing we can do. To the reverse, which requires a map. Now, one of the ways to get around that, when I covered if we're going to do pretty AST parsing. Just want to cover if we are going to do pretty AST parsing. But I don't want to do. I see what you're saying. So you're saying the only time that map lookup would be okay. If we do that, then we actually have to have two structures internally that implement it. We're implying that you'd have to have an array lookup for all the same numbers, and then you would also have to have a map that's literally identical. However, since the AST is supposed to be auto-generated from the grammar itself, that's not a problem, right? Keeping them synchronized, all that shit. If you're managing that by hand, it wouldn't be an issue. So I think having a redundant map and an array is fine in this case. Does that make everybody happy? In which case we just need to, I mean, this is just if we have a okay. So yeah, if we do that, no type as integer, can create the map from the way when the grammar is initialized. Yes, we can actually. We can do that in the init. That's probably the best thing. Yeah. I mean, it's either way. I mean, it's not. It's just code, right? It's just, do we want to pay a little bit of init performance to build that thing at startup, or do we want to? And that's actually what the init was made for. It's another one of those things where I'm kind of better with generating it because it's more portable if we're going to port to Rust later. Putting stuff in the init method, there might not be an init method in another language. One time and only if nodes are being used. If node types, yeah. Well, yeah, but you can't. I mean, it's whatever. Let's just, because we have code generation involved, let's just be okay with it being kind of verbosely included as a map, if that's okay. I think it's the best solution long term. This stuff isn't going to change very much at all anyway. So I think it's better to bite off on that one extra creation at code generation time than it is to incur any overhead whatsoever for what could easily have been codified from the very beginning. So yeah, that answers that. That does mean though, however, that we're going to need, so we do need to create some accessors for this kind of shit. No type strings. We should probably get the NodeTypeMap. Let's do that. The NodeTypeMap would then be a string int, and that's what you wanted before. Why am I spelling that wrong? What is up with that? Oh, duh. There. That's what we want. All right. So, and the node type as integer is just a lookup from the map. That's it. That's all that is. Yeah. So let's just do node type is integer. And this is just a lookup from NodeTypeMap. That most implementations will do that. And that way internally we have a map and we have an array. I'm actually going to do that right here. Grammar represents the identifiers, and PEGN notate and PEGN contains identifiers, and PEGN grammar so that it can be communicated to the parser for use in error messages and other parsing contexts that require yeah, that's like is normally, let's see, for best performance, the node type strings should be contained in both an array with a set number, by the way, in both an array and a map. It has both an array best performance, the node type strings, let's see, node type strings should be implemented as an array corresponding to the integer of the node types. And yeah, I fight really much with declaring node type, because then we could just use a string and we could just print it. I seriously fight with that, but then every time we set a node type, we'd have to declare it as a node type instead of an int. It'd be super fucking annoying. So it is pretty annoying. All right, so implement it as an array corresponding to the integer. The integer index of the node type constants. Of the node, of node types. How's it going, Mac? The node, if I don't write this, I'm going to forget. So if the node type map contains the same information as a slower map, oopsie. This is a little bit annoying. Identical. I made a mistake. Oh gosh. 2 months off. No much. What the hell happened? Yeah. Let's see. PEGN.dev. PEGN.dev. You can go read about it. Yeah, it's not Piggly Knight's replay file. No, it hasn't been picked up by searches. Not yet, anyway. I kind of want to change that. Non-reference to. Oh, it's sad, Mac. But yeah, I mean, you're going to be still doing lots of great code. Do I dare tickle Firefox? No, let's do this. I want to do just a quick search. Sorry for the distraction, but just to answer that. DuckDuckGo. PEGN. Fuegos. Prego. Report them PEGN. PEGN bumper, or whatever that is. I have no idea. The PEGN file extension about PEGN files. This is like really old. I'm going to take this over. It just hasn't been discovered yet. I don't. Is there a way to tell DuckDuckGo about an existing site? I don't think there is. I do not know if there is. It's only been, the site's only been up for a while, a little while. I don't like Firefox actually. Maybe you can make some Duck SEO tricks. Yeah. Submit your site to DuckDuckGo, the wealthy affiliate. This is gonna be some shit. All right, fine. Thus safeguarding your privacy, blah blah blah. Seriously, this is one of those things where you have to click on a next page. God damn, I hate shitty websites. Oh my god. Click the next button to get more advertising. Shitty websites. Shitty websites. If you go there, you'll be able to find out your site has been indexed and available in the search results. Well, all right, that answered my question. Duck to the go. Site dev.pegn. Whoops, pegn.dev. Dyslexia. Further kicks in. Nope. All right, now what do I do? Oh, I have to join to get the answer. Really nice. Thanks, Kate Katai, or whatever the fuck your name is. The chances are, if your website has been around a while, you'll see plenty of results. My website has been around, but that doesn't mean anything. They also crawl all those other blah, blah, blah. Straight to Bing and Yahoo. You've been indexed by them. Actually, I forgot. You can submit to Bing. Actually, that's how I got my site picked up last time, was I submitted it to Bing. His name is King. He does look like a nice guy. He looks really happy and nice. I mean, he's obviously taken time out of his schedule to write this. You know what? I went through this. It's just a good memory. I remember doing this. I actually did this with another site. I had to submit it to Bing to get it picked up. Yep. And then, yep. And then submit URLs to Mixmaster Bing. Let's put it blah, blah, blah. What are you saying? I have to actually have logged in. URLs. Submit URLs to Bing. URLs. Bing.com. Let us just submit URLs to Bing. Okay, well, let me do it then. Batch URL submission API. Ooh, you have an API for this. Very nice. How about don't I have just a place I can go and fill something in? Do I have to log into Bing? How's it going? Random YouTube search for Golang. Glad I was bored today. Welcome to the Twitch channel. Yeah, you can submit sites to search engines. Seems undemocratic. It totally does. Hey Peter, it still doesn't tell me how to do it. Root domains. Click submit using the submit URL. Request code increment. Blah blah blah. Submit URL or submit URL. Fingerprint webmaster using the submit URLs to get the web. Blah 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 blah. To Bing programmatically or using simple URLs feature in the configure my site section of the Bing webmaster tools. Obviously, I need to sign in. Oh my God. I feel so dirty. I feel so dirty. I do not care that much. Not that much. All right, I'll bore everybody with that another day. Not right now. All right, so let's actually do some Go stuff. Are you, Greg? Okay, appreciate the help. But yeah, I mean, that way at least people would find it instead of the stupid Pegly game. I'm sure it's a wonderful game. I'll get dirty for you. The sacrifices you've made. Well, I tell you what, that will keep me that will keep me on track. All right, so grammar contains identifiers from PEGN grammars so that it can be communicated to the parser for use in error messages and other parsing contexts. For best performance, the node string types should be implemented as an array corresponding to the integer index of node types. The NodeTypeMap, however, contains identical information. The NodeTypeMap contains identical as a map, but should not be used but should generally not be used. Not be used since the index lookup. Let's see, that's kind of awkwardly stated. Faster. It wants verification that the site is mine. Are you kidding me? Oh my God. Well, sigh. I also have to go tickle Google's nose and tell it it's there, but I refuse to put Google shit on there. Yeah. We have to play that game for now until KnowledgeNet's built. All right, so I think this covers the main things, actually. This is, you're just looking for other sites that are indexed. Yes, you can, and it will get picked up. And I have some of those. Frankly, if you're in the sound of my voice and you want to help me out, put a link to PEGN.dev on your site. Those inbound links really look sweet to Google SEO. Yeah, isn't that stupid? They actually reward you for having inbound links and fewer outbound links. It's just so crazy. Don't start me on that rant, man. They're literally destroying the World Wide Web by promoting and paying people to not link to other sites. It's literally the antithesis of the reason the web was created. And Google pays you more money if you do that. And like if you read this SEO snake oil shit, it'll like tell you all the ways to get a better SEO rank. And the number one thing they say is don't outbound link to anybody, because then you're not a quote authority. Such bullshit. But you can play the system. There's this girl, I read a blog about her. She completely dominated. She got all of her art seen. It was the top hit in Google. And what she did is she went out and she had everybody make sites that inbound linked to her site, and it shot her SEO to the top. Yep. And so much so they had to kind of tweak their algorithm. They're always doing that. Black magic. And you know what? You shouldn't have to try to guess some Google engine's black magic in order to get your site to show up on the top. That is so fucking broken. Okay. Okay. I'm going to calm down now. We have my interface. I have my interface. And I have to come back from that. I can't think about our world right now. I just get really pissed off. Don't get mad. Get busy. Ah, nice coffee. It's only 11 o'clock, man. Got lots of good coding left here. All right, so interface is finished for now. This is all I really need. And this is turning to be simpler. It's turning out to be simpler than I had hoped. Oh yeah, boy, I know that. I've read all about that. And yeah, coffee. It's lunchtime. Yeah, and have you seen Janeway? She drinks coffee at 4 a.m. Man, keeps the anger away. Actually, it's the opposite for me. It actually makes me angrier when I drink coffee. So you can probably tell. Hey, I have a visitor. Hello.
I'm coming clean. I bought the Happy
Wife.
Series.
You bought something? What did you buy?
Happy-ish. And it's just
You bought Happy-ish?
making me so happy.
The whole series?
This is only one season.
I want to go watch it. You're watching while you pack and stuff.
Yeah, but it's just brilliant. I'm just gonna say
It is so awesome. It's so brilliantly done. It shows you all the problems of advertising and how it's destroyed our world. It's just happy-ish.
No, like we could be their friends.
We could totally be their friends. Happy-ish, people. Let me pick a plug. My wife just bought the whole series. We watched it many times. I've watched it twice, but we now have it. Happy-ish. So a little. It's not for everyone. My wife, interjects a disclaimer from the back room. Because she's like, not everyone's us, and she's like, they could be our best friends. they'd be like people we would hang out with. One of our favorite quotes in that is, and we've both been healthy most of our life, but there's one quote from the guy. He's looking at this like totally ripped human being, and he's like, how much do you have to hate yourself to look like that? Because of the amount of time it takes to keep yourself looking like that. It's got so many great quotes. And yeah, and one of the guys is like studying the Nazi advertising book. Yeah, it's just insane. It's just really, really, really good. All right. Very Gen X. All creatures great and small if you want true escapism. Ooh, I'll have to try that one too. All right, so we've got a grammar here, and we have these main things I need to communicate, and I'm gonna convert those over right away. But it doesn't need to be that complicated, to tell the truth. So anything that implements that interface is good to go, and can be set as the grammar. If you don't have a grammar, you don't necessarily. You know what? This is another thing too I like about this is you don't have to have a grammar built in if you don't want to your parser. You can just parse it without a grammar, without knowledge of a grammar, and then we'll adjust the implementation of the parser to adapt. So if it doesn't know what it is, it'll just say, okay, I don't have this rune. I don't have this is function, which means the is function may not have a name, and that is actually something I need to add. I need to add it right now. I'm glad I mentioned it. So we need to have node type strings, node type map, node type as integer. Yeah, and this is not anything that's ever going to be set. This is designed to be coded, and then you just make sure you have these things in it. Yeah, I think we need to have the is functions. Yeah, so is functions. They're actually class functions. You know what? They're classes is what they are. Redundant by our description. Which one? The map is redundant by our description. The node. Yeah, we already talked about this, Mac. Yeah, I know. We had a big fight about it. Greg and I have recovered from our small fight. It should say the reverse. Not the same. Wait, which one? We have to have it, Mac, because because the map is slower on lookup, and we only have to do that in isolated cases. Otherwise, we lose our speed from our index lookup. Because node types are integers, and they are directly one-to-one comparisons to the index for the string names. But the reverse lookup, the one is int to string, other is string to int. Okay, so node type has integer, which is string. Node type map, we got that. Node type strings. Identical information, I think. Oh, you're talking about up here? Okay, the node type map contains, I don't know. We can get, for best performance, the node type strings should implement as array corresponding to the integer index of the node types. Node type, let's see. That's all I'm going to say. I don't need to mention the other thing. It's like, we good on that? I don't want to confuse people. The node type strings should be implemented as an array corresponding to an integer index of node types. Yeah. Yep. How about for correct operation? No. Am I wrong? I think, so what we have, so tell Mac the situation. He does with C stuff all the time. And C stuff is all about the arrays. Because making a hash map is expensive, right, Mac? So this is what I'm trying to do here, is I want the AST to just use integers, and I just want the integer to look up the names in the one-way direction by just looking up their index in the names array, the strings array. Whatever, types or whatever. But we have a case where we have to, an isolated case, where we have to reverse look up the name and get its integer. And short of writing our own, binary sort or whatever, writing our own hash algorithm to go through the array and identify it, which we could do, we have a situation where having a redundant map which uses the built-in hash map capabilities of Go to look it up. So we end up with a redundant list of the names because we have one that's just, it's an array of strings. And then we have another one that's a hash map of strings that returns an integer that matches, the other thing. And so that's annoying, but those, that's obviously it's two copies of it in the implementation, but both of that bit of code is auto-generated. And we talked about having an initializer that actually generates the map from the array on startup. It's one hit on startup, but then not every potential ported language is going to have an init capability or something like that. And it's just code generated anyway, so it's just extra code space for the map at the beginning. You should build up a map structure yourself. Abstract NodeTypeMap anyway. I already have that. So Mac, that is very much a C coder's answer, and I'm all about that. Actually, Greg, that might be a fun project. How about I give you that project? So, hey, there's your computer science, data structures and algorithms, right? Write us a hashing algorithm. No, seriously, check it. So if we do this, we can drop this thing. We don't need this anymore. All right? So if you write your own hashing algorithm, you know what I'm saying? If we write our own hashing algorithm, we can actually do the lookup and do the whole search stuff. I kind of like that, actually, because that means somebody's actually using one of our lookup algorithms that comes from Computer Science 101, and we can use it as an example, like which algorithm, which sort you're going to use. Do you want to do that? I mean, you might not want to do that. The other way to do this, of course, is to just the cool thing about doing that, Greg, is that if we do it that way, we have the freedom to write our own hash algorithm, our own sort, our own lookup. So we can optimize it based on what we're doing. We use a Go map feature, but build it up with node type string. Yeah, we just talked about that. Yeah, but the point is Mac is building it up like that is something that doesn't have to be done in this case because this code is generated. So because it's already generated, I can actually write, during the generation process, we can create a map that has one-to-one the value that we need. It's like static. It's not really, you know what I'm saying? So it doesn't, having anything run at all to make this is sort of, but then there's the other option, which we've been talking about, which is if you make a really, really efficient map lookup, which you're going to have anyway, right? If you use Go's maps, then there is a lookup code running. So the question is, how can you make your map lookup faster than Go's map lookup and avoid the hassle entirely? And that's actually a kind of a cool challenge. I'm kind of jealous. I want to do it. So let me put that out there. If anybody's out there. So yeah, implement us an implementation of NodeType as integer, where it looks up the number from an array of strings and gives us back the number that is the index in the fastest way possible. So this is where all of your traditional computer science hash sorting and stuff like that's going to come in, right? Because how are you gonna search that list of 200 names? Obviously you could do it linearly, but would that take longer? So just a linear search is not that fast. I just would not be using this a lot, but I have a feeling you can get it faster or as fast as the Go hash. You could even look in the Go source code and look for its hash map feature and see, because it's definitely going to be the most efficient possible. Do you know what I mean? You could go digging through the structure. Keep the interface as simple as possible. No redundant interfaces, please. That wasn't a redundant interface. Yeah, this is so. Yeah. Yep. No type of string. In this particular case, the reason I have both an array of all the strings and a lookup, which is effectively just going to call into this thing, is because, well, I don't want this. The type is integer. We don't need that at all. Tell me I need that. I don't need it. I kind of don't want to have it, because if I have this, people will use it instead of caching all the strings up front. See what I mean? And if this is just calling into the string, then it's totally redundant. Keep asking this, and every time I say you must do parser per AST. No, I'm not. I'm talking about something else, Greg. I'm talking about the other one. So we agree that we need type as integer. We both agree on that, and we need to write we need to write a thing for that. What I'm asking now is a different question. Do we actually need node type as string? Because this is now redundant with this. Because if I provide a way to get the actual slice, then I can just look it up. You know what I mean? Yeah. So I think this should just go away. That's what I was at. That's what I was talking about. Because heck, this is return. Okay, even underneath, this is even so highly performant. You could even call this, because this is slices. Slices are just pointers. So if you return this, even if you cache it, all you're caching is a pointer. So it's like one indirection. Otherwise, you're calling this, and you're giving it an index, and you're good to go. So at that point, I'm inclined to do this instead. Node types, and yeah, I think this is fun. Do you so actually I do believe this would be a good exercise in like chapter 1 of computer science algorithms, finding it the fastest. And I kind of want to do it. But if you do it, go for it. people ask why do I need to know data structures and algorithms, and I'm always poo-pooing on them, saying, oh, you don't really need them. And you don't actually need them in this case. We could just do a map from Go and use Go's. But this is a case where, it's probably not that much extra work to write our own sort and search. And so might as well do it. I wonder how much memory it would use. It is a slice after all underneath. Actually, no, this is important. No, we have to make it a slice. The reason we have to make it a slice is because when you have an array, you have to expend. So Go has this cool thing where you can do ... And when you define the array, it will automatically define an array of that given size. The problem with that is that you can't, when you're trying to return it and stuff, you have to return a slice that covers it up anyway. Because otherwise you have to know the exact size, I believe. I need to test that, actually. I need to test that. I've been wanting to mess with that anyway, so give me a second here, guys. This is related, I promise. So yeah, Quentin was doing this the other day. Quentin, are you there? He's the one who showed me it. I hadn't known about it before. I really need to read through the Golang spec. I've gone through almost all of it, but this is one piece that I'd missed, and particularly all the new stuff on errors. So make directory Go arrays. So people who are playing around with Go arrays, you know what? I'm gonna make a break, guys. I'm gonna stop the stream and start a new one with a different title. See you in a bit.